Assalamualaikum and hello everyone. Today we will be presenting a steady flow device. We choose the diffuser as our device to present. My name is Muhammad SHAFIQ bin Muhammad NAZRI as a first presenter, and I hope everyone will enjoy the presentation. Okay, let's start with what is a diffuser. Diffuser is a device for reducing the velocity and increasing the static pressure of a fluid passing through a system. Let's move to the next slide. Diffuser in aircraft. The diffuser is the divergent section of the engine after the compressor and before the combustion section. It has all the important function of reducing high velocity compressor discharge air to increase pressure at a slower velocity. This prepares the air for entry into the flame burning area of the combustion section at a lower velocity that the flame of combustion can burn continuously. If the air passed through the flame area at a high velocity, it could extinguish the flame. The figure shows the diffuser in turbine. High velocity air from the compressor section enter the diffuser where air velocity decrease and air pressure increase to a maximum. Okay, next, shape of diffuser. Diffuser can be as a shape of round, rectangular, or can be as a linear slot diffusers. Linear slot diffusers take the form of one or several long, narrow slots, mostly semi-concealed in a fixed or suspended ceiling, with air falls behind the slots, directing the airflow in the desired direction. It consists of inlet and outlet, narrow inlet, wide outlet. Okay, next, design of diffuser. Diffusers are designed to reduce the kinetic energy, in other words, velocity, of a moving fluid as illustrated in figure below. They are categorized under steady flow device which raise the pressure of fluids. Commonly, diffusers do not have any heat interaction similar to nozzles since they are designed to be adiabatic. First, diffuser consists of insulated wall. And second, diffusers are mostly used in reverse fashion as air inlets or returns. Next, operating principle of diffuser. As air leaves an axial flow compressor and moves toward the combustion section, it is traveling at speeds up to 500 feet per second. This is far too fast to support combustion. Therefore, the air velocity must be slowed significantly before it enters the combustion section. The divergent shape of a diffuser slows compressor discharge while at the same time increasing air pressure to its highest velocity, increasing value in the engine. The diffuser is usually a separate section bolt to the rear of the compressor case and ahead of the combustion section. Okay, next, application of diffuser. Diffusers are very common in heating, ventilating, and air conditioning. Diffusers are used on both all air and air water system as part of room air distribution subsystems and several purposes. For example, first, to deliver both conditioning and ventilating air. Second, evenly distribute the air flow in the desired direction. Third, to enhance mixing of room air into the primary air being discharged. And fourth, to create low velocity air movement in the occupied portion of room. And the last but not least, accomplish the above while producing the minimum amount of noise. Okay, that's all from me. Thank you.
Assalamualaikum and hi everyone. My name is AFIQ and I will talk about what happened to the fluid in diffuser. Okay, before that, let's recap back on the designs of the diffuser. Okay, as we can see here, the designs of the diffuser is divergent. Therefore, the fluid enter the inlet sections will be under these conditions. The pressure decrease and velocity increase. With the help of the diffuser design, it will force the fluid to enter outlet sections of the diffuser under these conditions. The pressure will increase and velocity will decrease. Why we need to increase the pressure? As we can see in aircraft turbine application, diffuser will place between compressor and combustion chamber. Therefore, in order to maximize the thermal efficiency, by reducing the losses is to make sure the pressure enter combustion chamber is high. This will improve aircraft turbine operation and to make sure fully combust in combustion chamber.
Hi, Assalamualaikum. My name is ALBAN and I would like to present about the detail of diffuser. Okay, for diffuser, the velocity at inlet is more higher than velocity at outlet, and area at the inlet is lower than area at the outlet. Next, the pressure at the outlet is greater than the pressure at inlet, and for the mass at outlet is the same as the mass in the at inlet. Q, which heat transfer, is 0. It means here there is no heat transfer between the diffuser and surrounding. Next, W, which is work done, is also 0. It means there is no work done by the diffuser. And lastly, Z inlet minus Z outlet equal to 0. This means there is no change in potential energy. Okay, moving on to the steady flow equation for diffuser. Okay, this will be a long explanation. Okay, firstly, we take basic steady flow energy equation, which is M inlet in bracket H1 plus V1 squared over 2 plus GZ1 close bracket plus Q equal to M outlet in bracket H2 plus V2 squared over 2 plus GZ2 close bracket plus W. Okay, from this equation we simplify based on the detail I have tell just now. Okay, since the mass at inlet and mass at outlet is the same, so we can dismiss them. Q and work is 0, so there is no need for them in this equation, so we cancel them out. And GZ1, which is the potential energy, also we can cancel them since their value is 0. Okay, from that we can derive H1 plus, we only left with H1 plus V1 squared over 2 equal to H2 plus V2 squared over 2. And from them we move the same at one place, which is H2 minus H1 equal to V1 squared minus V2 squared over 2. That is the steady flow energy equation for diffuser, which is I would like to tell about the M is mass, V is velocity, H stand for enthalpy, Z is elevation, and G, which is gravitational acceleration. Okay, moving on to the conservation of mass. Okay, the fluid formula for conservation of mass is rho inlet time velocity inlet time area inlet equal to rho outlet time velocity outlet time area outlet. And the next one is mass flow rate equal to mass flow rate 2. And next, I would like to tell a formula that need to be taken into consideration, which is either gas formula, which is P stand for pressure equal to rho RT. Rho is density, R is specific gas constant, which can be found in the property table, and T is the temperature. Okay, that's all from me. Thank you.
In conclusion, diffuser have helped to increase aircraft turbine efficiency with the application of the concept Bernoulli's principle. Therefore, diffuser have also utilized the fluid to reduce the fuel consumption in aircraft turbine system. This will also reduce environment pollution and noise pollution. This is the end of our presentation and we will see you in the next video. Thank you.